Morning, everybody. Welcome to day 2 of Authenticate. How many of you have heard of Taco Tuesday? Today is not Taco Tuesday. Today is T-shirt Tuesday, also known as the day after UPS found our T-shirt shipment. So if you haven't gotten your T-shirt yet, get one outside of the reg desk on your way out. Before we get started today, I want to take a moment to thank our breakout moderators. So the different sessions we're having are moderated by my co-executive director and partner in crime, Christina Holka, David Turner, Director of Technical Standards, and Megan Shamus, Senior Director of Marketing, who's also yesterday wore a smashing Authenticate green suit, so you couldn't have missed her. So thank you, Megan, for doing that. A couple other housekeeping items. First of all, take time to visit all of our sponsors, please. And there's some great companies kind of out that way to the left, towards the windows. Really interesting solutions, so take a couple minutes to visit them too, if you get a chance. Tomorrow, we have a great agenda all the way through to MoPOP. So we have closing keynotes from Amazon, Microsoft, and more. Do come to MoPOP. MoPOP will be great to attend. MoPOP, you need your badge, so please bring that with you tomorrow. So with that, let's get rolling with the morning keynotes today. As you know, payments are a center point for FIDO authentication. We're seeing all sorts of issues that passwords bring to the table when it comes to transactions. Later today, we'll be releasing our annual authentication barometer. One finding we found was that roughly half of people we surveyed had abandoned a purchase due to passwords within the past month. So that remains an ongoing issue. Payment fraud is a big issue. So we're very fortunate today to have Doug Fisher, Senior Director of Visa, to talk a little bit about Visa's perspective on authentication, delegated authentication, and more. So Doug, please come to the stage.
Thank you. Hello, everyone. Glad to be speaking here this morning, and I'm glad that we had such a good turnout. I was sort of thinking that given this is the first session of the day, that maybe people would choose to sleep in. Hopefully, by the end of the presentation, you don't regret the decision to show up. We'll see. My name is Doug Fisher. Been with Visa for 20 years, doing all things authentication. I work in the authentication and identity team at Visa, and I also represent Visa at the EMVCo 3DS working group, working on the 3DS specifications. So I'm going to be talking about how FIDO is actually reshaping digital payment authentication. Don't worry about this slide. Everything's above board. And I'm not going to spend much time on this slide because I think everyone knows how quickly e-commerce is growing and what a big issue e-commerce fraud is. The numbers are truly staggering. On the good news side, online authentication is being very helpful to help reduce that online fraud. And we do see a lot of global momentum on EMV 3D Secure. And just from a Visa perspective, in just over 1 year, we've processed over 6 billion 3DS authentication transactions globally, and over 95% of the issuers are already have already adopted 3D Secure. So that is really good. We have an option for merchants to get online authentication for e-commerce to reduce that fraud. But there's still significant challenges. When we look at how e-commerce transactions from an authorization perspective perform compared to e-commerce transactions, the performance is definitely reduced. So 98% authorization success rate for in-person transactions compared to only 80% for online e-commerce transactions. The really big issue is the amount of abandonment that happens during the online checkout process. And the amount of abandonment is definitely a major issue that needs to be addressed. Why is that abandonment occurring? Well, one reason is because of excessive friction during the checkout process. I think it's something that we've all experienced as we try to get through an e-commerce checkout experience, how often we're asked to go through a challenge process to prove our identity that is very cumbersome and difficult to get through. So the friction of these authentication methods and the fact that too often consumers are being asked to be challenged, their identity being challenged too often. If we can improve the or reduce the number of challenges and decrease the amount of friction, we would be able to address the cardholder abandonment problem and improve e-commerce transaction performance to what consumers expect to get, like when they go into an in-person store, just tap their card and they're done. So what I'm going to be talking about in this session is how FIDO is being used now to address these challenges. And I'm going to do that through sharing 2 use cases for how FIDO is being used. And before I get into that, just let you know some of the work that's been going on. I'm going to start back in April of 2019 with the formation of the Web Payments Security Interest Group. And this was a joint effort by the FIDO Alliance, the W3C, and EMVCo, recognized that the 3 technology bodies had compatible technologies, and if we work closer together, we could increase usage of those technologies, we could increase interoperability, we could reduce and make it simpler to use these technologies. So that was the goal of the WPSIG, and since its creation, a few things have been done. One is the creation of a white paper, How Technologies Relate, which is really quite useful and is available to explain all these technologies, some background, and how they interrelate. So that's an educational piece. The other big achievement is a developing standard called Secure Payment Confirmation, and I'm going to talk about that in like 3 slides or so. And that is something that we're quite excited about. In addition to the work that's going on through the WPSIG, FIDO and EMVCo have collaborated on a number of white papers. And those white papers, the objective of the white papers is really to say that if you're using FIDO, let's say you're a merchant using FIDO to authenticate your customers, and you want to share the fact that you did do FIDO authentication with the issuer who has issued the payment card to the cardholder, the white papers explain the data format to be shared, the specific data elements in a specific consistent format so that the information, when sent through the 3DS messages, can be digested by the issuer and used in their risk authentication process. So 2 of the white papers are available on the FIDO website. The one on the right is available through the EMVCo website. But basically, what they're doing is addressing one of the key objectives, which is how do we reduce the number of challenges that take place during online shopping. And what happens is that typically in 3DS, there's 3 different types of data: the device data, transaction data, and account data that comes into the issuer. When they get that data, they look at the risk of that transaction, and they decide whether a challenge is necessary or not. Hopefully not. But sometimes the issuers do have to invoke a challenge to prove the cardholder is who they say they are, to reduce fraud, and that causes the friction during the checkout process. So now, with these standardized data sets that can be shared in the 3DS messages, the merchant can provide evidence that they actually did do a FIDO authentication of their customers. So they pass up like the relying party ID, the authentication time, the AA GUID, and data elements like that, so that the issuer can see that, yes, a challenge has already been performed, and therefore there's no need to challenge the consumer a second time. And that's really the importance of these white papers and the effect that they have. If you look at it from a process point of view, you have a merchant who's checking out a consumer on their website. They're using 3DS for online payment authentication. They are the relying party. They, the merchant, or their payment processor has implemented FIDO and is using it to authenticate consumers to their website. When they go through the checkout process, the merchant will provide the data in the format specified up to the issuer through 3DS, and then the issuer will be able to take that into account when they decide whether to challenge or not. All right, straightforward. In this use case, this first use case of how FIDO is being used within the payments authentication space, I just want to point out that this is considered a first-party use case. So first-party in that the credential that has been created, the FIDO credential, is being leveraged by the merchant who created the credential. The merchant is the relying party. I want to contrast that with the next use case, which is a third-party use case. So in this use case, which actually is a very typical way that payment authentication is done, it's actually the credential is being used in a third-party context. So I'll explain. You have the same merchant who has a customer who is going through a checkout process. They need to get authentication for this transaction from the issuer through 3DS. But in this case, it's the issuer who has the credentials that will be used to authenticate the cardholder. And in this case, the issuer is using FIDO to authenticate that cardholder. During the checkout process, since the merchant is trying to minimize friction, the one thing that merchant does not want is to redirect the consumer from their website to an issuer website in order to leverage the issuer's FIDO credentials in a first-party context. The merchant wants the consumer to stay in their domain. They want to be in charge of the user experience. And from a WebAuthn perspective, they want to be able to invoke the authentication ceremony themselves. On the flip side, you have the issuer, and they want to authenticate their cardholder in a very effective manner. They would prefer not to deal with the challenges of trying to format and render a user experience across all different devices, all different browsers, all different browser versions. They would like the cardholder to get a very seamless, effective UI to reduce those abandonments, to reduce friction. Okay, so because WebAuthn currently does not allow the merchant to invoke an issuer FIDO credential, EMVCo, FIDO, and the W3C came together to create SPC. And I'll explain what SPC is. But first, just a show of hands, how many people have heard of SPC? So I would say 5%, maybe? Okay, so for those that haven't heard of it, hopefully this brief explanation will suffice, and I'm just checking my time here. So what is SBC? I mentioned that the merchant has needs, the issuer has needs. These are conflicting needs. The consumer is trying to get this frictionless experience. So how do we resolve this? And that's actually what SBC does. So in SBC, what happens is that the merchant retains control of the consumer checkout experience. They invoke the authentication ceremony using the issuer FIDO credentials. And we have a new player in the process, which is a supporting SBC browser. Google Chrome is currently supporting SBC. So the role of the browser is very interesting because that, from a consumer perspective, is the first trusted component that we have in the e-commerce realm. The browser can be trusted to display the transaction details to the consumer. So it's not the issuer having to properly render an interface on that consumer's device. It's not the merchant who is displaying the interface and possibly misleading the consumer in terms of the details of the transaction, possibly if it's a recurring transaction or installment transaction, that type of thing. So the consumer is getting a transaction confirmation screen rendered through this trusted component. The merchant is able to invoke and do FIDO within their domain. And through the invocation of the SBC API, the merchant is able to create cryptographic evidence that the consumer has seen the transaction details, approves of them, and has gone through their biometric gesture to sign that information, and then be able to, just like in use case 1, provide the results of that signature, the assertion, to the issuer to validate that the authentication was properly performed. So we believe that through the role of the browser displaying the confirmation screen, that that's going to increase consumer confidence of using FIDO and biometric authentication because the display has been standardized through the browser. I mentioned the superpower of SBC because it's operating on top of WebAuthn, which is to enable cross-origin credentials. And from a EMV 3DS perspective, if the device doesn't support SBC, there's a problem. The consumer has an option to cancel out of SBC and so forth. For any non-happy path routes, the authentication process just gracefully degrades to normal 3DS. What does it look like? This is a typical 3DS challenge using OTP. You could notice every issuer decides on how to implement the authentication process, but this is a typical OTP process where the consumer is being asked, how do you want to receive the OTP, your email or through your phone? The consumer would specify, oh, send it to my phone. They receive their OTP, they enter it in, and then they're done. Contrast that with SBC authentication. The consumer is on a merchant website. They hit the buy button. The one screen that they see is the SBC confirmation screen, which tells the consumer that they're purchasing, X dollars at Y merchant using this particular payment instrument. If they decide to continue, they could cancel out. If they continue at that point, the next thing they'll see would just be the prompt to do their biometric gesture. They would, FaceTime or use their fingerprint to actually do the authentication, and then the authentication is done very seamlessly. And if you look at it from a process point of view, I'll explain it at one level down in detail. We have the consumer who's on a website. We have a merchant who's trying to get payment authentication for that consumer's purchase. And we have the merchant using 3DS for payment authentication. So in step one, I'll use this right screen. In step number one, the merchant signals to the issuer that SBC is supported. And then on this side, if the issuer also decides to use SBC, then what will happen in step two is that the issuer will respond back to the merchant with the credential IDs that exist for that cardholder's PAN, as well as providing those UI elements that appear in the confirmation screen, like the amount, the merchant name, that type of thing. So that goes back to the merchant. And then in step three, they invoke the SBC API using the credentials that match for the issuer in the consumer's browser. The participating browser invokes the confirmation screen and for that particular payment instrument, and the browser displays the UI. What's interesting is that those details that the issuer provided in the confirmation screen, the amount and merchant name, what happens in the SBC API is that that information forms part of the challenge that the authenticator will sign through WebAuthn, so that when the signature is received back by the merchant through the API, that assertion will travel through the 3DS messages, the issuer will receive it, and then they will be able to confirm that, yes, this is the right transaction, the right amount, the right merchant, and so forth, and the FIDO authentication was properly performed, successfully performed. All right, so that's how it works. And we are very excited about this authentication method for a number of reasons. We think it addresses the challenges. We should remember that this is still an experiment, and there's still work going on to define, prove out the value proposition for SBC, enhance the user experience, and so forth. But we're really excited about this, and I think it's a really good example of what power comes about when the industry collaborates on issues. WebAuthn didn't necessarily address the payment use case, certainly not the third-party payment use case, but through working together, it was really quite outstanding, and it really is a credit to the folks in the W3C, FIDO, and EMVCO that joint effort caused this new authentication method to come into existence. There's education that's going on about SBC, and just about a month ago, there was a webinar put on by EMVCO, W3C, and FIDO about SBC, and that webinar is available through the EMVCO website. And it's just the start of an education process that we're going through. And as far as next steps, we're really encouraging additional collaboration. We'd like to see SBC mature and evolve into a fully developed specification. We're doing some work jointly with FIDO and EMVCO on the working papers that I showed you in terms of the format of the data, trying to enhance that. And we're working on testing, prototyping, piloting SBC such that it can really realize its potential for online payment authentication. In our opinion, SBC and FIDO go together like peanut butter and jelly. Okay. Thank you very much.